Okay, so here is the video for Unit 2, Lesson 5. Again, this is Compound Inequalities number 2. Number 1 was and compound inequalities. Now we're going to do the or one. So my learning target, I can solve and graph or inequalities. So last lesson, we talked about the first kind of inequality, again, the and inequalities. And for that, we had to find all the numbers that made both both parts of the compound inequality true. Today, we're going to talk about the second type, which is the or inequalities. So here's an example: or inequalities. Find a number greater than 10 or less than 3. So there's two conditions here. You just got to make one of them true. So the first condition covered up a number greater than 10. So number greater than 10. The second one is less than 3. So number less than 3. And notice there's no numbers that meet both criteria. There's no number that can be more than 10 and then also less than 3. So it can't happen. So we don't even need to look for an and for this, but there are some that could do one of the conditions. Some numbers that can make one true. So for this one, we'd say numbers greater than 10 or numbers less than 3. And that's pretty much it. So notice there's no special notation. Yesterday we needed to have the arrows point to the left. We wanted to go from least to greatest. Today, you must, the only condition is you must have the word or in the answer. So you got to have the word or in there. A solution to this type of compound inequality is a number that makes one of them true. It just doesn't have to make them both. Yesterday I had to make them both true, today just one of them. In the above example, there are no numbers that make both true. But there are an infinite number of solutions to each inequality by itself. So there are infinite numbers larger than 10. There are infinite numbers less than 3. So if I just have to meet one of the criteria, there's infinite solutions to this, or compound inequality. So again, we can't list them all. We will show them. To show them, we need to graph. Again, in this case, I want 3 and 10 are the important points. So I want all the numbers less than 3 or greater than 10. So it looks something like that. Okay, now a little bit of work to do here. We've got some inequalities, and this one should be a plus. Okay, there was a typo in there when I printed this off. Should be a plus. So I want to solve this compound inequality. I want to find all the numbers that meet this or meet this, one or the other. So to solve these, simplify each inequality individually and then combine it using the word or. Okay, so solve them individually. So first off, take that first one. I got 4x plus 3 is less than negative 5. Subtract 3. I got 4x is less than negative 8. Divide by 4. So I got x. X is less than negative 2. Okay. Don't need to switch the arrow. Even though it's negative, I didn't divide by negative, so the arrow stays the same. And then or, I got negative 2x plus 7 is less than 1. Subtract 7. Negative 2x is less than negative 6. Here I'm going to divide by negative 2. Because I divided by a negative, the arrow switches. Okay. So I want all the numbers less than negative 2 or greater than 3. So my numbers of interest here, and no equal to, because they're both open circle, all numbers less than negative 2 or greater than 3. So notice nothing meets both requirements, but there are a lot of numbers that meet one of the requirements. Okay, down here below we've got solve this or this. We're going to solve them individually. So add 2, divide by 3. I want to put the x first, so x less than or equal to 2. Or, in this guy here, I'm going to multiply both sides by 4. So if I multiply this by 4, I get 5x plus 2 is greater than 32. Subtract 2, 5x is greater than 30 divided by 5, so x is greater than 6. Okay, so it's got to be meet one of those requirements. So at 2, less than or equal to 2, again equal to, and then 6 just greater than, so open circle pointing to the right. Okay. Next one, again solve it just like we normally do. So I'm going to distribute the 4 out, so 4x minus 4 is greater than 5x plus 2. Subtract 4x, so we got negative 4 greater than x plus 2. If I subtract 2, I got x on this side, negative 6. Now I want to write the x first, so I'm going to have x first, the arrow is pointing at it, and then negative 6. So x is less than negative 6. Or over here, if I bring the 9 over, I got negative 9 is greater than negative 3. And notice I divided by a negative, so now the arrow switches. Okay, so it's pointing at the 3. I want to write the x first, but I got to make sure the arrow continues to point at 3, so it would be all the values greater than 3. So I've got negative 6, open circle less than that, and then at 3, open circle to the right of that. Okay, 2 more on the back. Okay, 2 more on the back here. Now, notice this guy here, there's no or in there. So it's what we did yesterday. This is actually an and compound statement. We threw it in there, so make sure you always look. If it doesn't have an or, this has an or, that's an or statement. This one is compound and. It doesn't have the word and, but it has something that meets 2 requirements. So this is one where you got to do 3 things. So every time I do something in the middle, I'm actually going to do it 3 times. So when I add 1, I'm actually adding 1 3 different places. So this would be negative 8, 2x, 32. When I divide the middle by 2, divide everything by 2. So we got negative 4 is less than x, which is less than 16. Equal to. Okay, so when you graph this guy, these are the x's larger than negative 4, but less than 16. So it's going to be between those 2 numbers. So negative 4, 16, open circle, close circle, and then graph between them. Okay. I want you to try this guy. So finish for credit. Remember, when you don't do these, I don't give you credit for your notes. You got to finish this last problem. So I want you to try one out and see how you did on that. So that's the end of the notes for today.